very good day to our lecture. Okay, today I would like to present about the Bernoulli theory experiment. Okay, my group mates are Muhammad Najari bin Sufyan and I, Satyara Ramalu, and another one is Amir Ishraf bin Ishamukri. Okay, first, what's about the problem statement in this experiment? In this experiment, Bernoulli's equation will be used to determine by using the Venturi device with manometers to calculate the pressure head and total head at various points in the flow rate study. Okay, next, the objective about this Bernoulli experiment is first is using Bernoulli's theorem devise a total calculation method for fluid flow, viscous and incompressible fluids, and next to show the pressure difference in the converging diverging pipe segment. And third one is to calculate a fluid state that isn't identified. For example, fluid pressure, velocity, density, or height. Okay, next we'll talk about the scope. Okay, the first is the Bernoulli's equation is obtained by assuming that the velocity of each liquid portion along a pipe's cross section is uniform. And second is the small amount of the kinetic energy is converted to heat energy, and energy loss occurs due to the shear force. When the liquid flows in the curved path, the centrifugal force is ignored.
Assalamualaikum warahmatullahi wabarakatuh. My name is Amir Ishraf bin Hishamukri. My ID matrix is MA17235 and I live in Kuantan, Pahang. So continuation from previous presentation. So this is theory of Bernoulli principle. So in this experiment, the discussion is the relationship between the pressure, velocity, and elevation of the flowing fluid. When the fluid flows horizontally, there should be no difference in potential energy, and the reduction of pressure corresponds to an increase in velocity of fluid. When a fluid flows through a horizontal pipe with a variable cross-sectional region, the fluid velocity increases in the constricted areas, hence resulting the least amount of pressure exerted where cross-section is low. So here's an equation we can use. So in this equation is P plus half of density and velocity times rho GH equals to C equals to constant. So from here we can get pressure over rho and gravity plus V square per 2G plus Z is equal to Z is H equals to C. According to the law of conservation of energy, energies at the input should be equal to the output. So P1 per rho G plus flow velocity square 1 per 2G plus Z should be equal to its counterparts here, Pn and V square n. So Z can be removed to give the above mentioned equation of Bernoulli's principle an easier understanding, from where we can calculate the height at any point of the flow if we have the initial height of flow and velocity at each respective positions. Hence we can get Hn. There are in the experiment is going to be 6H. So here's the result. Yes, we can get the equation, the calculation for H1 to H6. So on to the methodology. So here are the apparatus. We have the pipette tube, Venturi tube, manometer, motor pump, water tank, water flow control valve, manometer valve, single pipette manometer valve, pipe valve, and a stopwatch. So in this figure here, so C is the multi-tube manometer for static head measurement, E is the pipette tube for total pressure measurements, and A is the Venturi tube. So the procedure is the pipe valve, the manometer valve, and the water control valve are all to be set up according to the provided diagram and properly, and each components are to be checked to be completely open, while valve number 2 is half opened. The motor pump is started by raising the speed of water flow from adjusting the water flow valve, and the overflowing of water in the manometer valve and the pitot manometer valve will remove any air bubbles from both manometers. The single pitot manometer valve and the manometer valve are then to be shut closed. The pump is stopped, the pipe valve number 2 was closed, and the pipe valve number 1 remained open. The manometer valve and the single pitot manometer valve are to be opened to allow airflow into the system. The pitot manometer valve and the manometer valve are closed when cross half of the columns, then reopen, and pipe valve number 2 is to be fully opened. Starting from tubing number 1 to tubing number 6, the water flow valve set to make sure the placement of all water levels in the manometer could be read. The pitot head and the static head measurements in the venturi tube were recorded, and lastly, the flow rate was recording based on the volume of the water and the stopwatch used to monitor and record the water tank raise. So this is all from me. Thank you very much.
Hi, Assalamualaikum and a very good day. My name is Muhammad Najari bin Sufyan and my ID is NA17230 and I'm coming from Raubah. Today I would like to present about the result, graph and discussions. So in this chapter basically we will discuss the result that we obtained from the Bernoulli's experiments. Okay, so this one shows the result where the given information is the volume, which is 5 liter equal to 0.05 meter cubic flow rate. We obtain 2.2727 times power of -4 meter cubic per second, and the time for the experiment is 22 seconds. So these are the tables which we obtain from the experiment by doing the calculations. So the first one, we have the table of intermediate and area of venturi tube, which is based on the points. The given is 6. So the next one is table 4.2, refer to the static head, pitot head, total head, and both measured and calculated dynamic head. And the last one is table of measured and calculated of velocity and dynamic pressure. So these are the sample calculations that we've done at point 1. So we have 10 equation. The first one is flow rate, and we have also area here, velocity that we measured, calculated velocity, and so on, as you can see in the slide. So we are doing this, we are using this equation for all points from point 1 and point 6. So the result is based on the previous data in the table. Okay, next we go to the graph. Okay, so as you can see here, we have a graph of static dynamic total head versus point. So this figure shows that all the dynamic static and total head were plotted in the graph against the points in the venturi tube. So we can see that both measured and calculated dynamic head are almost the same in pattern. As we observe, the major peak for dynamic and static head is point 3, where there is an anticlimax, or the lowest point for static head, while the maximum peak for dynamic head is calculated on 1 since it is slightly higher than the data obtained or measured from the experiments. So the small difference in the dynamic head may be from consequence of measurement errors or parallax errors during carry out the experiments. The next one is dynamic pressure versus point. So both measured and calculated dynamic pressure show almost similar pattern corresponding to the dynamic head in figure 4.1, which is the previous graph. So the measured peak or maximum value are located at point 3. So despite of both not showing obvious deviations, calculated dynamic pressure shows the highest peak at point 3 as compared to the measured value of dynamic pressure. So the last graph shows the velocity against point. So we can see that the graph shows a very high peak at point 3, where the internal diameter is the smallest at point 3. The pattern shows that all type of parameters such as dynamic pressure, dynamic heat, and velocity indicates point 3 as the highest peak. From here, we agree that the experiment showed the correct result and correspond to the theory of Bernoulli's principle. Small internal diameter resulting in small cross-sectional area of ventral tube leads to the higher velocity, dynamic pressure, and dynamic heat. So, as the conclusion, was this experiment successfully carried out? Okay, actually, Bernoulli theorem is shown to obey the equation as a result of the experiment. So we may deduce that it is accurate for fluid flow based on this. As the segment's area shrinks, velocity increases and pressure decreases. The experiment also demonstrates Bernoulli theorems of energy efficiency in a streamline. There will also be inconsistency as a result of this experiment, resulting of inaccuracy in the data obtained, random error, as well as variable not used in Bernoulli equations such as points being slightly off kilter contribute to the error. As a result, they weren't perfectly aligned around the same axis. Since the fluid and rigid surface are in contact, frictional losses arise. That's all from us. Thank you.